Hey guys, today we are going to look at the law of cosines. We've already looked at the law of sines. Today we're going to look at the law of cosines. So let's think about what we have. And you know, angle, angle, side would be where I was like given this angle, I was given this angle, and I was given this side. Okay, so angle, angle, side. The order makes sense. If I have angle, angle, side, is it hard or difficult? I mean, is it easy or difficult?
Easy.
It's easy, and I just use the what?
Law of sines.
Law of sines. What if I have an angle, a side, and an angle? Angle, side, angle. Is that easier or hard?
Easy.
It's easy. I do the what?
Law of sines.
Law of sines. Okay. If I have the angle, side, side, and that's where, like, I have this angle, and then I have this angle, I have this, I don't have that, but I'm given this side. Is that easy or hard?
Wait,
Angle,
that's not
angle, side. I'm sorry. I messed up there, I'm sorry. I have the angle, and then I have this side, and I have this side, but I don't have this angle. Is this easy or hard? This is hard because you don't know. There's different possibilities. You might have no solution, you might have one solution, or you might have two solutions. So that's our earlier lesson. This is a really hard one, and we end up using the law of sines, but you got to really figure out how many solutions that you have. Okay. And then similarly, if you had side-side angle, that's also the same because it's like the angle is not between the two sides. Same thing, it's hard. Okay, now we have other cases. What if I have side, side, side? Like I give you 3, 7, and 12. Can I use the law of sines? No, because I don't have an angle. All right, that one's not hard, but that one you can't do with the law of sines. And what if I have side, side, angle? Okay, or I'm sorry, side, angle, side. Side, angle, side. Similarly, you can't do it because if I have this, this, and this, same thing, you're going to run into problems when you try to work it out because this one doesn't have that one, this one. You don't have any where you've got both sides of it. Okay, so we need something new. And what it's going to be called is the law of cosines. The law of cosines. I actually think the law of cosines makes a lot of sense, and it's as easy as the law of sines. So for the law of cosines, those are for side, 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 and side, angle, side. Over here, the law of sines, we use it for angle, angle, side. We use it for angle, side, angle. And then if we have angle, side, side, we use it. But we put the star there knowing that this one is tricky. But you would be over there. We're going to look at how to do these. So I'm going to kind of show you. We're just going to start with what we know, and then we're going to end up with the law of cosines. Okay, so I'm not just going to tell you the law of cosines, I'm going to show you how we get there. Okay, so let's think of a right triangle. Okay, so I've got this. I would label this A. I would label this B. I said it, but I didn't write it. I would label this B. What would I label this?
C.
C. Okay, what do I know, right, if you just see this? What is someone going to scream out at me?
It's a right triangle.
Uh-huh, and what would you say about A, B, and C?
It's a side.
No, what would you say about A, B, and C? What?
Oh.
Which is?
A squared plus B squared equals C squared.
A squared plus B squared equals C squared, right? Mm-hmm. That's you know really, really well. Okay, but what you have to see is, does A squared plus B squared equal C squared always work? What? It has to be what?
A right triangle.
A right triangle. And you know what? That's really, really easy to forget. Because, you know, I would bet, I should have done this. I should have done this. I should have given you this triangle, okay, and called this A, and called this B, and called this C, and then like given you a problem, and you know what you would have done? You would have worked it. And what's the problem with you working it?
It's not a right triangle.
Not a right triangle, so that's not true.
Mm-hmm.
Makes sense? I bet I could have fooled you on that, Ben.
Maybe.
Okay, maybe not. I don't know. Okay, so what you have to see is that if you have the general case where this is A and this is B and this is C, okay? This is little c, and then this would be big C, and this would be angle big B, and this would be angle big A. This is a general case, right, where there's not a 90-degree angle. So for this case, c squared is equal to a squared plus b squared. So far, so good, right?
Mm-hmm.
But then what we have to do is we have to minus 2ab cosine c. Now you're going to see it's kind of nice that when I have the c out here, what ends up here? The big C.
Mm-hmm.
And if the big C is here, then what's out front? A and B. See, there's going to be a lot of symmetric cases. Now tell me something, like, look at this big angle C and tell me something that would be true, like if something about C, what would happen here? What would be a possibility of a special C that you could have? What if C was what?
Which C are you using?
This one.
Oh.
That one.
Okay.
What would make this a special triangle if C was
90 degrees.
if C was 90 degrees, then this would become a what?
A right triangle.
Okay, so let's see what would happen. What if C is 90? What is cosine of 90? Oh, don't get your calculator out. What is cosine of 90? Zero.
Zero.
Okay. Did you really get your calculator out?
No, I didn't use it.
Okay. So it's 90. So if C is 90, this whole term goes to what?
Zero.
And I'm left with what?
A squared plus b squared.
Yeah.
Do you,
Okay,
do you
that
see the
makes
magic?
sense.
So this, I wish we would teach you this to begin with, because this is always true. Okay? And when C is 90, you get the special case. Okay? So, I'm going to write this. This is the log cosine. C squared is equal to a squared plus b squared minus 2ac cosine of big C. Now I want, Ben, you tell me what,
Isn't it 2ab?
2ab, thank you. Thank you, ma'am, 2ab. Ben, I want you to tell me what b squared would be, just kind of by symmetry.
B squared would be C squared.
Let's say a squared, so we go in order. A squared plus
C squared.
c squared.
Wait up. Wouldn't it be C squared minus A squared plus
What?
2AB cosine C?
No. Okay. What am I solving for here? C squared?
Yes.
Okay. I'm solving for c squared. And then what are the other two squared terms?
A squared and B
The
squared.
ones I'm not, right?
Yes.
So now I've got all three, right?
Yes.
And then if I have what I'm looking for here, what angle do I use in the cosine?
C.
And out front are the other two what? Sides,
Yes.
right? Okay. So Ben, tell me what b squared would be.
B squared would be C squared? No. A
It'd be
squared plus
plus C
C squared.
Okay. Why do I want you to put a squared first?
To keep it in order.
Yeah, to keep it symmetric. What you were saying was not wrong, but it doesn't reveal the symmetry. B squared is A squared plus C squared, and then what?
Minus 2AC
2AC
cosine big B.
cosine B. Okay. Catherine, could you tell me what A squared is going to be?
A squared equals. Yeah. Okay. So A squared equals C squared plus B squared.
In the right order.
B squared plus C
Okay.
squared.
What you were saying was not wrong, but it just comes out a lot easier to remember. A squared is B squared plus C squared minus
2CB
2CB.
cosine of big A.
Order! Alphabetical order.
2BC
Thank you.
cosine of big A.
Cosine of big A. Okay. Everything that you told me, Catherine, was right. Okay. But do you understand why I want to put it in the right order? So it's like C squared is A plus B, B squared is A squared plus C squared. So you see, it kind of brings out the symmetry of this. So really, if you know this one, you can, just remember this one, and if you can remember this one, then the other two you can figure out. But I would rather you memorize one, and then just from it get the other two, rather than try to memorize 3 different things. Does that make sense?
Yes, sir.
Okay. So let's think about this. Let's think about this. So let's say that I gave you A is equal to 8, B is equal to 19, and C is equal to 14. Okay, this would be angle what?
8.
Big A.
Big A,
C
big C,
B.
big B. So what kind of triangle is this, Catherine?
One that you can solve with and side, side, side.
Side, side, side.
Yes.
Okay. And what you were going to say was also right, one you could solve with the law of cosines, right? So you're thinking the right way. Okay, so like, let's just write one down. What's the first one that we did? And always write it down.
C squared equals A squared plus B squared minus 2AB cosine of C.
Okay. So let's think through this, because I mean, is this enough? Is this enough to work the problem? Tell me something, like just talk me through this. Like,
So you have C.
I have C,
You have A.
I have A,
You have B.
I have B,
You have A and B again,
A and B.
and then you just need C.
So is this good news or bad news?
Good.
Good, right? Because there's only one thing that I need. So I need to get C by itself. So what I could say is big C by itself, C squared minus A squared minus B squared is equal to minus 2AB cosine of C. All right? Now, what is it that I'm trying to get by itself?
The two. You're trying to get cosine of C.
Yeah, so what would I, Catherine?
So you can divide both sides of the equation by minus 2AB.
Yes. So I'm going to say C squared minus A squared minus B squared over minus 2AB is equal to cosine of C. Right? Would everybody agree with that?
Yes.
Okay. So what could I say? C is equal to what?
Oh, the cosine inverse.
And why am I smiling? Because you didn't say divide by cosine, right? Because dividing by cosine, no, you've got to undo the cosine. And so C is equal to cosine inverse of C squared minus A squared minus B squared equals minus 2AB. I want you guys to see that I am showing you a way to work problems that will allow you to be successful in physics, okay? Because what are we not doing as we're working down here? We're not what yet?
Plugging those in.
We're not plugging in numbers, okay? You get it in the right form, and when you get it in the right form, then you plug in the numbers. Because what you're going to start trying to do, if you just plug in numbers, you're going to jump to the calculator and you're going to start punching into the calculator, and you're going to make a mistake. Now, it is possible to just put in the numbers and work through it with the calculator, but it's much more likely you'll make a mistake. Always bring it down to what you're looking for, and now we are going to what?
Plug in the numbers.
Okay, so C is equal to cosine inverse of,
14 squared
thank you, 14 squared
minus 8 squared
minus 8 squared
minus 19 squared
minus 19 squared
over negative 2 times 8 times 19.
Okay, now use your parentheses and make sure, like anytime on the calculator tip here, anytime on the calculator, put parentheses around the denominator, okay? Because if there's a plus down there and you don't use those parentheses, you're going to get the wrong answer. So always put parentheses around your denominator, and if you get in that habit, you're going to do a lot better. So what do you get for C?
Just 1 second.
$41.12.
Okay, and let's come over here. What did I forget to do? A equal, B equal, C equal, A equal, B equal, C equal, right? We should always do this because we'll get our, we need to keep track of our bookkeeping. So A is 8, B is 19, C is 14, and now we have big A, or big, what did we do? Big C is 41.1. Is that right? 41.1?
Yes, sir.
Okay. 41.1. Boom. Okay. Now, let's get big B. Okay? If I want big B, what should my cosine have?
Your cosine should have B.
Should have B. And if cosine is B, what two things are going to come out here?
AC.
A, C, and a what?
A 2.
Minus 2. How about that? And then what two things am I going to be adding?
A squared plus C squared.
A squared plus C squared is equal to
B squared.
B squared. Do you see how, right? Does that make perfect sense? Okay, so now we're going to say B squared minus A squared minus C squared over negative 2AC is equal to, okay. And now if I want to make this just B over here, what do I need to put here?
I'm sorry, what?
Oh, cosine inverse.
Cosine inverse, right. So I just unwound this to this just like we did in the other one. So now we're just going to say B is equal to cosine inverse. And Catherine, can you help me with the numbers so I can just look at what I'm writing?
Yes, sir. Okay, so it's going to be 19 squared
19 squared
minus 8 squared
minus 8 squared.
minus 14 squared over negative 2 times 8 times 14.
Okay. 19 squared minus 8 squared minus 14 squared over minus 2 times 8 times 14. Who is our friend at this point?
The calculator.
The calculator is our friend at this point. Okay, so what do you get for B?
You get I got 116.8.
Boom. Ben, did you get that?
Yes.
Catherine, did you get that?
Yes, sir.
Okay, and the reason I want each one of you to do it is to make sure that you're doing the calculator right, because you got to kind of do that right. So B is 116.8. And making sure that we're working in degrees, right? You've got to make sure your calculator is set right. Okay, so now we need to find what?
Hey,
Okay, now on the first step, when we found, what was the first one that we found? C first? The only way that you could get C was to use the what? That was the only way. All right. But now, if you really think about it, what were two ways that we could get A or two ways that we could get B?
We could have gotten B by using the law of sine.
We could have. Did we get the right answer with the law of cosines?
Mm-hmm.
Yeah. So on A, what are our two choices? We can use what or what?
Law of sines or law of cosines.
Let's,
Or
Or
you
you can
could
use the
do
calculator.
180 minus B minus C.
why don't we do it that way? What do you get?
22.5.
Yeah. At this point, to get the last one, you could use law of sines, you could use law of cosines, or you could just know they add to 180. That was smart. I was fixing to do the law of sines, okay? Okay. Let's do another one. Okay, so I always like to start with A equal B equal C equal A equal B equal C equal, so we can kind of do our bookkeeping, right? Keep track. So here we're going to have C is equal to 12, the angle A is equal to 25, and little b is equal to 9. And then I've got this side, which is A, and then this would be big C, and this would be big B. You see, big B is opposite little b, big A is opposite little a, so it's just, this is the naming convention. It doesn't matter what you call A, B, or C, but they always need to line up like this, okay? Now, what is it that I have here?
You have a side angled side.
So how would I start this?
With the law of cosines.
With the law of cosines. And so, you know, I think what I would like to do, I would like to find little a. So,
you need
I
to
would
use
say-
the cosine of big A.
Yeah, a squared is equal to what?
B squared plus C squared minus 2AC. No, 2BC, sorry. Cosine of big A.
Okay, so now let's think. Do I know what a is?
No.
No.
No. What do I know?
You have B is in C. You have B and C again and cosine of A.
So why are we happy?
Because it's already by itself.
It's already by itself. Hey, Jose, come in. What's going on, sir? You gotta go ahead and finish this lesson for me? Do you remember the law of cosines? It's been a while. So that's what they're working on. How are things going today?
Going pretty good.
All right. Do you know these folks in here?
Sure, yeah.
Okay. Do you remember Cameron Caps?
Yeah, I know helping.
Okay. This is his little brother Tanner. Tanner's just like a math genius. He's just like this crazy math genius. He's not even in this class. He just sits in here. And so he's in Algebra 2, and he just sits there, and I gave him the pre-calculus test, and he made 100 on it. So he's pretty smart. Benjamin McGee, okay. And Emmy Grace Minette, so that was Will's little sister, and Ivy Kate's little sister, if you remember Ivy Kate. And then Catherine is Catherine. So let me finish the problem here and make sure I'm doing it right, okay? So a squared, so we'll say a is equal to the square root of, okay, what's b?
9 squared.
9 squared plus
12 squared.
12 squared minus 2
Times 9 times 12. Cosine of 25.
cosine of 25.
Now, don't we need a plus or minus in front of?
Let me think. I don't think so.
No, because you can't have a negative.
You can't have a
Yeah,
negative on an
Okay,
A, but
just
good
kidding.
thought. Always, always think, do I need to put the plus or minus? So who is our friend now?
The calculator.
The calculator. And so what do you calculate A is based on this?
is 12.
A is 12?
That's what I got.
5.4 is what I
Boom,
got.
5.4. Try it again, okay? Ben, what did you get? Any day now. 3.3. That's wrong.
Relax.
Okay, I want you guys to get the right answer because if you're not understanding something with the calculator, we need to get it. We need to get it straight. So, square root, big parentheses. What'd you get?
What the heck? Okay. Square root, big parentheses.
Oh my goodness. Catherine, I'm glad somebody knows that.
It's not
This-
often that I'm the one that gets the right answer and stuff, so it's okay.
If you don't know how to use a calculator, Ben, that's not a bad thing. That means we're really teaching math.
I didn't use any parentheses.
Okay, I got it.
Okay?
5.4.
Okay, Ben, I got to move on. You got to figure it out, though. You have to understand why you're not getting it, all right? So 5.4. Okay, what else did I know? I know that B is 9, right? I know C is 12. I know big A is 25. And now I have to find B and C. So how am I going to find B? Let's do the law of sines. So sine of big B over
Little b,
is equal to
sine of big A over little a.
sine of big A over little a. And what are we trying to get to?
Little.
We're trying to solve for
B.
little a. We're trying to solve for little what?
B.
Or we're trying to solve for big B, right?
Yes.
So so what are we going to do? Can we do this in one step? B is equal to what? Sine inverse.
Sine of a times little b over a.
I'm going to say little b over a sine of a. Did everybody catch that right? What do? I put the b over here, multiply both sides by b, and then take the sine inverse. Now b is equal to sine inverse of what's little b?
It is 9
Over
5.4.
sine of 25.
Yes.
And then what does that come out to? For those of you who know how to use a calculator, you get what?
$44.78.
44.8 we're going to call it.
Okay.
44.8. Very good. Now what's the easiest way to find C at this point?
Subtract A
Yeah.
and B from 180.
Subtract A and B from 180 and I'll just tell you 110.2. Okay? So you see we got all three now. Does this make sense?
Yes,
Yes,
sir.
sir.
You can handle this, right? You can handle this. All right, one more. Okay? One more. I'm just trying to check here. Okay, so let's look at one more thing. All right. Let's say that I have a triangle. And I give you A, B, and C. And I want to find the area. Okay? Now the problem is, you know that it's 1/2 base times height. Well, you know the base, but you don't know the height. So you would have to go in and you would have to figure out the height, and then after you had the height, then you could go in and do it. But there's a way that you can do it directly, and that is area is equal to, I'll tell you what S is in a minute, but it's S times S minus A times S minus B times S minus C. Okay, what is S? S is equal to A plus B plus C over 2. Okay? If I were going to do this on homework, I would just put this into an Excel spreadsheet. I would say this is S, okay, and this is A, B, and C, right? And so you put in A, you put in B, you put in C, and then you say this is equal to, right, that. So now Excel figures out S for you, right? And then you say here A, and then what do you put here? A is equal to this, 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 this. And you can click up here to get S. And then make sure that you got it in Excel right. But once you do, then verify it for a problem that you have the answer to. And then just go like that and get all those homeworks done. Does that sound good?
Sounds good to me.
Or you can just do it the old way by hand if you want to. I would do it in Excel. Okay, this is Chapter 6, Section 2. This is Chapter 6, Section 2. And the homework is 5 through 8, 13 through 15, 37 through 40. The bonus is 48. The bonus is 50. The bonus is 54.